Hello and welcome to my tutorial on work and power. So work is the word of physics whenever energy is transferred. So usually you need a force to move something because you have to overcome another force. So you have to overcome friction when you move a box, and you have when you jump you have to overcome gravity, but gravity is always stronger, so you come back down again. And the thing being moved has kinetic energy while it's moving. The kinetic energy is transferred to another form of energy when the movement stops. So work is the amount of energy transferred. So lifting the box, it's done against gravity, and the final energy form is gravitational potential energy. Touching the spring is friction, and its final energy form is heat. Pushing the chair across a level 4 is the stiffness. Oops. It's got nothing to do with Hooke's law. How embarrassing. Right. Let's have a go. It's actually wrong way round, so bear with us. So pushing the chair across level 4, it's done against what friction is going against friction, and it is output as heat. And stretching the spring, the stiffness of the spring constant K. See more about Hooke's law in future tutorials. And the final energy form is elastic potential energy. So moving on now to W equals Fs. So work is the energy that's being changed from one form to another. It's not necessarily the total energy, and the distance needs to be measured in meters. So you need to convert any other distance to meters, because the formula is force in newtons times the distance moved in the direction of the force in meters. So the units you're going to have is the Newton meter, and the force F is a fixed value in any calculations, either because it's constant or because it's the average force. If you are asked to take the mean force, you add the two forces together and you divide them by 2. So 33 plus 33 all over 2 would be 33, but that's what I mean. You need to take the mean and divide it by the number of forces acting on it. Usually it's no more than 2. The equation assumes that the direction of the force is the same as the direction of movement, and the equation gives you the definition of the joule. So 1 joule is work done when a force of 1 newton moves through a 1 meter distance. And to calculate work done in a situation like this one, you need to use the horizontal component formulae. W equals Fs cos theta. Cos theta is just the horizontal component. So it's the force times the distance moved in the direction of the force, or S, and cos theta is the angle basically on the horizontal. So looking at the sledge, if A is the force on the sledge and B is the motion of the sledge, the A would be the force, and then the motion would be the force times cos theta, because it's going in that horizontal direction. So now we move on to the next equation. Power is work being done per second. So power is equal to work done over time, or P equals WT. Or if you prefer multiplying, P equals FV, where the V is the distance moved, and the rot is the rate of energy transfer equal to 1 joule per second. So that's what what is the definition of power. That's the worst joke you're gonna get in physics ever. So if we look at this P equals FV example, and if I had a force of 500 newtons and I moved it 10 meters, then I would get 5,000 watts out of it per second. You can also use this arrangement for horizontal components only, and most questions will say whether it's a horizontal component or not. So we'll have a look at some questions now. A narrow boat is drawn by a horse walking down a towpath. The horse pulls the boat between two locks that are 1,500 meters apart. The tension in the rope is 1,000 newtons and at 40 degrees to the horizontal. The work done on the boat is 114,900 joules, or 105 kilojoules, 76.6 kilojoules, or 115,400 joules. And the next one, a motor is used to lift a 20 kilogram load a height of 3 meters. So we let G equals 9.81, and we calculate the work done in lifting the load. The speed of the load during the lift is 0.5 ms minus 1. So you just use that one there. Calculate the power delivered by the motor. So look at the answers now. Drawing a diagram always helps. So 100 cos 40 equals 76.6 newtons. That's the horizontal component. Then we use W equals Fs. 76.6 times 1,500 equals 114,900 joules, or 114.9 kilojoules. So it's A. That is all full marks. I'll give you a mark for the diagram because it's a good practice to get into. But the actual question is only worth 3 marks. So for question 2, we use W equals Fs, and then 20 times 9.81 times 3 is 588.6 joules. So we're working out the weight, times in that by the velocity, and we get that. So P equals FV now, working out the power, and we have the weight again, times by 0.25, and we get 49.05 watts. Okay, so that's it for this tutorial. Thank you for watching, and see you again soon.